Okay, so this is my task 2. This is my Arduino to Max project, and this is basically just a simplified Max controller which transfers data from several hardware components through the Arduino and into Max. Now, the simple serial is the basis of the patch that I've created. And this is one that's available in the Learning Resources folder from Christian. As you can see, I've added my little modification signature here, and it basically just consists of 6 inputs which are analog and 4 inputs that are digital, so a total of 10 inputs. So you can see it's set up here, and the main purpose of this patch is to pretty much send all of the data that's coming through the hardware into a serial port, which you can see. I'll just bring it up real quick. If it will play. So you can see here we've got an array being transferred, and the first 4 here are the 4 controllers for the pitch of each step in the step sequencer, which is the patch I'll show in a second. So that's this one, this one, this one, and this one. So the 4th potentiometer, which I've got plugged in, controls the gain on the patch, which you can be seen going down at the end. And we also have an LDR, which detects the intervals between each step. Now I also have 4 digital inputs, which are buttons, which you can see if I press, you'll see like just a momentary 1 just goes up, because obviously 1 on, 1 off. And this data is then transferred through to my Max patch, which is here. So I've taken one of my old patches with a translation mechanic, and what this does is it starts removing data from the serial port outputted by the Arduino patch and brings it into Max, available for it to be translated into numerical values to be applied to different things. So this is the simplified view and the presentation view. If I just explode it, you can see here that I've got quite a large and messy patch, which basically just consists of the translation patch here takes all the data values which are coming out of the serial port and applies them to each one of the things. They're obviously labelled down here. It's got pot 1, pot 2, pot 3, pot 4, the LDR and the gain potentiometer, and then these here are the toggle ons and offs for each one of the steps which are here. So the tempo, or rather the intervals, are controlled by the LDR, so you can just see I'm just touching it now and bringing it off. That's controlled by obviously light exposure, and each one of these are toggled on and off by the digital buttons. So you can see here, turns it on and off. Now I had to take into account the sample rate of the board, so obviously 9600 is the standard, and obviously the output of the data from the Arduino, I didn't want it to be so slow that the digital read function wouldn't take into account the quick clicks from the buttons. The quick clicks from the buttons would be missed if the read delay was too slow, obviously because it's quite a quick transfer of data. But I didn't want it to be so fast that it would crash everything, because there's quite a lot of stuff going on. So we can see here that the each one of these is basically just triggered by the buttons, and if I just do a quick demonstration, you can see the gain going down here with the gain potentiometer and the pitch being controlled by, for example, one of the pitch potentiometers for each one of the steps, and these are the buttons on and off.